This talk is about increasing digital agility in retail with asynchronous API management. My name is Jochen Trauniger. I'm a principal solution architect at Solace. First of all, what is agility? Agility is the ability to move quickly and easily. This means for digital agility in retail to be able to quickly and easily optimize omnichannel customer journeys, integrate a multitude of applications and systems, provide personalized customer experience, participate in partner networks, and increase supply chain efficiencies. Fundamental capabilities of the underlying information system in retail are the ability to quickly and easily connect and integrate, add, move, replace, and change, monitor and observe, govern and manage individual components. Liebig's law of the minimum, which originates from natural ecosystems, can also get applied to technical ecosystems like an information system. It states that the rate of growth depends on the scarcest of its essential nutrients. What are the limiting factors in the context of digital agility? For instance, the engineering teams. The ERP team might be a bottleneck with several projects executed in parallel, asking for all kinds of tailor-made interfaces. A spaghetti integration architecture, where a slightly change of one system could have unpredictable side effects. And legacy systems, which are limited to batch jobs, or integration is only possible via file transfer, or the lack of near real-time updates. Before deep diving into async API management, let's repeat fundamental features of API management. First of all, it's about the decoupling of the contract lifecycle, the API, and the service lifecycles. For developers, API management is the one-stop shop or yellow pages for all consumable services within the boundaries of an enterprise or exposed to partners and third parties. Service developers can offload cross-cutting concerns like authentication and authorization, enforcement of policies, monitoring, tracing, and logging to an API gateway. Typical API specifications supported by most API management solutions are Swagger and OpenAPI, SOAP and WSDL, GraphQL and OData, gRPC and Protobuf. But there are also proprietary specifications like IDOC, EDI, CSV, and even spreadsheets. The fundamental building block in API management is the API gateway. A typical API gateway acts as a reverse proxy, supporting HTTP and WebSockets, maybe raw TCP IP connections, REST, SOAP, and GraphQL. For authorization and authentication, basic auth, API keys, OAuth, and certificates are supported. Some API gateways have the feature of load balancing and failover. Metrics tracing and logging is a key part of API gateways, and policy enforcement, like rate limiting or enforcing quota. Some API gateways even offer middleware capabilities like header manipulation or payload manipulation. This diagram shows typical building blocks of an API management solution. There's a management plane, the data plane with the API gateway, and a control plane. The service developer provides API specifications of a service and uploads them mostly through a provider portal into the management plane. The API team manages the API lifecycle. The application developer searches for APIs and subscribes to them, and instruments its applications with an API key, which invoke the API gateway, and finally, the gateway invokes the fitting service. What's missing in today's API management solutions? Real-time event-driven APIs are yet not commonly supported. Async API and cloud event specification support is missing, and feature-rich async API gateways beyond WebSockets, supporting MQTT and other messaging protocols. Brick and mortar supplies is an example motivating the benefits of async API management, especially in retail. It's a simplified scenario combining typical retail use cases. Brick and mortar supplies has a typical organically grown information system. They removed their spaghetti architecture and replaced it with an hub and spoke integration platform. This consists of an integration middleware, serving SOAP services, JSON REST services, quite a lot of batch jobs, and even more file transfers. Brick and mortar supplies is right now in the middle of its digital transformation process. The first step has been adding an online shop as a digital sales channel. A small team of internal engineers installed and configured an online shop system hosted by some hyperscaler. They integrated the online shop via VPN tunnel with their hub and spoke integration platform. The online shop was and is a great success, but with success come challenges. The web shop customers expect up-to-date stock information about all the enlisted products. Pick and collect needs near real-time stock updates of all physical shops. Frequently polling the ERP system and warehouse management system through synchronous APIs would induce a heavy, not acceptable load on these systems. And further channels at marketplaces and a new CRM system are already waiting to get integrated. The solution, a digital agility platform. Of course, an event mesh must get added to the architecture landscape. The ERP and warehouse management system and the webshop and online chat channels are getting event enabled, and they are going to introduce a unified API management solution to expose synchronous and asynchronous APIs, to foster self-service for engineering teams and enforce governance processes, because all integration traffic must flow through API management in the API gateways. In this picture, we can see the entire digital agility platform of brick and mortar supplies. It supports synchronous and asynchronous paradigms in parallel, and teams can pick whatever paradigm fits best for a specific integration task. Online shops and channels and CRM systems will get implemented by independent third parties or contractors. These contractors and third parties will engage with brick and mortar core systems only through API management, synchronous and asynchronous. In the following demo, this scenario will get implemented. The warehouse management system publishes stock level updates as asynchronous APIs, and stock level information can get retrieved by a REST API. The online shop will consume both of these APIs through API management. By following these 4 simple steps, the entire process of exposing and consuming synchronous and asynchronous APIs will get shown. First, the architects engage and use a PubSub Plus event portal. In that portal, they manage the events and schemas, and they create asynchronous API products. The API team in the second step uses WSO2, which is an open source API management solution, API publisher, to manage the lifecycle of APIs. They upload the async API specifications or products into a WSO2 API publisher. They enrich these APIs with metadata, and they manage the lifecycle by publishing them and introducing versioning, etc. In the third step, the application developer will discover APIs in WSO2's API developer portal and will subscribe synchronous and asynchronous APIs. And in the last step, the online shop, mocked by MQTT Explorer and Postman will invoke async and synchronous APIs through gateways. The synchronous API gateway will get provided by WSO2 out-of-the-box API gateway, and the asynchronous API gateway is a Solace PubSub Plus message broker.
This checklist will guide us through the demo. First, as an architect, I'm going to create an async API product in Solace Event Portal. This is Solace Event Portal with several toolings like the designer or the API products editor. First, we'll check the catalog. There we see already populated events like the master data item action or the stock update event. We are interested in the stock update event. The topic address of this event is like that. And there's already a schema associated with it. It contains the SKU, the new stock, and the old stock information. This event we are going to use for our async API product. In the async API product editor, we're assigning that event to the product. Stock update event in here. We'll mark it as a publish. This might be confusing, but with async API specification, it's always the perspective from the broker publishing events into the application. We'll release that and host a dedicated website. This is the async API product we just created with the channel and the update payload inside. We're going to download it and we'll reuse it later. Back to our checklist. We created an async API product, we published it, and we downloaded the specification. Next step is, as a member of the API team, to expose that async API product in WSO2 API Manager. We're using the web UI of API Manager and logged in as the API team. There's already a RESTful API published, Central Warehouse REST API. We're going to add now the async API by importing it from the recently downloaded file. It got identified as Solace Event Portal API. We'll give it a context update inventory and a version, version 1. Now this async API got populated into WSO2 API Manager, and we can add further metadata to it. We can tag it, the warehouse, and we can assign an API category to it. It's an async API. Furthermore, we can add documentation, like a quick start, and just provide some content. The topics of the async API are enlisted here again, including the payload we've seen before. We also see the raw async API specification, and we could use the editor in here to adjust that async API. Next step is to make that async API accessible for developers. First of all, we're going to deploy it into Solus PubSub Plus broker as a async API gateway. Next step is to get it published for application developers. Now this API is accessible for developers as it's in the state published. Back to our checklist. We imported the async API, provided a quick start, and published it. As an app developer, I'm going now to the API developer portal. I'm going to subscribe to that async API, create an application, and subscribe to it. This is WSO2 developer portal. I'm in the role of an app developer. And in developer portal, I can see all the published APIs that are accessible for me. This is this one-stop shop or yellow pages place, the place to go to find APIs. In here, I can search for categories like async APIs, and I get presented the API just created by the API team. I can make myself familiar with that API by looking into the definition. I see the channel and the payload as expected. I can look into the documentation with the quick start we just created. I can also add comments. This API looks great. And this comment will be presented to the API team. To subscribe to that API, I'm going to create an application for the online shop. This application represents the online shop with all subscribed APIs to it. I'm going to create access keys, like the consumer key, and I'll note that for later use. The same with the consumer secret. Also, I'm going to generate an access token, which will be used for the REST API. The API manager also supports OAuth as an authentication protocol. That one we will not use right now in this demo. With that application, there's yet no subscription available. By that, I'm going to subscribe to APIs. I'm subscribing to the REST API and also to the async API we just created. Both subscriptions are on hold. By that, we need to approve it. Back to our checklist. We subscribed to the async API, and now, as the next step, as a member of the API team, I'm going to approve that subscription request. There's a portal presenting all the tasks, and two tasks are waiting for us to approve central warehouse online shop asking for access to. Let's accept that one and that one. We approved the subscription requests. Now, as the last step, I'm going to validate if everything works out as expected and the application can ultimately consume the events and invoke the REST API. For the async APIs, I'm going to use the tool MQTT Explorer. I'll add the username and the password we just copied. I already subscribed to the topic we're interested in all stock level events. And we are connecting to solid pub sub plus broker and waiting for events to arrive. The first one arrived. It's the inventory update of the stock item saw. So we got 31 new stock items and we had an old stock of 0. By that, we got a delivery of 31 new stock items. We're waiting for further events to arrive. The planner got decreased, nails got decreased too. By that, these events are flowing in now. Next step is to validate that the async API, the RESTful API is also working. So for that, we're using Postman. As authorization, it's the bearer token. This one we're going to change to the one we just created. And invoke that API. Here we get the entire list of all stock items. Getting back to our list, checklist. We've validated that we can access it via MQTT client and with Postman.
We have shown in the demo that event-driven architecture and async API management actually increases digital agility in retail. We achieved optimized omnichannel customer journeys by providing real-time stock updates and available information. We integrated the online shop with the backend warehouse management system via API management, and we enabled partner developers through API Developer Portal. By that, EDA and async API management increases digital agility in retail. Thank you for listening.